Let's start. Welcome everybody to our fifth session of this webinar series on asset management of underground infrastructure. My name is Bert Bosseler. I am Scientific Director of IKT and I am your moderator during this webinar. My colleague Thomas Brüggemann is organizing this session today and he will take care of the microphones and any technical questions. Our subject today is the asset management of wastewater infrastructure in the United States. And I'm very happy to be able to welcome two renowned speakers for this subject. First, it's Graf from WERF, that's the Water Environment Research Foundation in the US, and then it's Sunil Sinha, professor at Virginia Tech University in Blacksburg, Virginia. But before we introduce our speakers in detail, let's take a look how we can call and how we can all participate in this webinar. First, I'd like to introduce Walter. Walter Graf is Program Director for Infrastructure Management at WERF, the Water Environment Research Foundation in the States. He has an MBA in Finance from George Washington University and a BA in Geology from the University of Tennessee, Knoxville. Sunil Sinha is Principal Investigator in WERF's projects on asset management. He has a PhD in Civil and Systems Engineering from the University of Waterloo in Canada. And today he is a professor of civil and environmental engineering at Virginia Tech, and there he is also the co-director of the so-called Center of Excellence in Sustainable Water Infrastructure Management.
Good morning, everyone. As Bert said, I'm the program director for infrastructure management here at WERF. I'll give you a little background on what we do here after the agenda. We'll have an introduction, which we've gone through. We'll have a little background on WERF. Next, I'll speak on asset management research at WERF, and also some other asset management research that we've been doing that's not related to our subscriber-driven program here. As Bert mentioned, Professor Sinha is joining us today, and he's going to give an overview of Water ID, which, if you haven't heard of this, is a pretty revolutionary knowledge base in the water industry, and I think it'll be of great interest to everyone. And then we will wrap up today's program. What does WERF do? We were founded in 1989, and we are America's leading independent scientific research organization dedicated to wastewater and stormwater issues. We provide research in 19 major areas, asset management being, of course, one of them. We also do research in trace organics, nutrient recovery and removal, stormwater, some energy work, among other things. You can check with our website to see the entire list. We're driven by subscribers, volunteers, investigators, and subject matter experts. So, you know, we are, since we're a subscriber-driven organization, our research is directed by those who contribute to us. We really work on delivering practical results that subscribers can use. So, although we have some highly theoretical research, we really want to try to put our efforts into the hand of our subscribers so they can use it right away. We've had over $120 million in funded research over the years. So how do we get started with this asset management research? We had a workshop in 2002 where we included participants from the United Kingdom, Australia, and New Zealand, as well as across the United States. We determined our biggest needs and research priorities, and then we developed a roadmap here depicted in this slide. Out of this, we came up with a strategic asset management challenge, which is a program-directed research effort here. We started before the actual program was fully developed with the condition assessment strategies and protocols for wastewater and utility assets. This report is structured for two different audiences: utility planning managers who want to embark on cost-effective condition and performance assessment programs to support long-term planning decisions, and also engineering and maintenance managers who need to identify and understand advantages and disadvantages of tools and techniques for measuring the condition and performance of utility assets. The selection tables that are also available in this 486-page document are based on inspection, survey, and condition assessment tools and techniques. And the selection process here had 4 components. We wanted to identify the types of tools that are appropriate to condition assessment applications. We reviewed the tool summary information to identify applicable techniques. We reviewed tools. Excuse this pop-up. We wanted to find the most appropriate tools to use, and then we wanted to undertake a benefit-cost analysis to consider the accuracy of the tool and the level of asset risk and available budgets. This report is free of charge. You just need to go to the WERF website to download it, and I've included the project number here. We also developed SIMPLE, the Sustainable Infrastructure Management Program Learning Environment Knowledge Base, which I'll talk about a little bit later. These 2 efforts were the precursors for the SAM Challenge, which commenced in 2007. First question is, what's the current state of my assets? And we'll go into this a little bit more in a few minutes. Second, what is the required sustained level of service? Because as you all know, service levels are the core of asset management as far as setting your programs and then your budgets that arise from that. Given my system, which assets are critical to sustain performance? So here is the question of risk. So this is where we examine the business risk exposure of your assets. What are my best minimum life cycle costs, capital improvement program, and operation maintenance strategies? Again, trying to fine-tune your management levels. And then 5, given the above, what is my best financing strategy? We'll go into this in more detail in a minute, but these are where we start from in our program. So here we go, the integration of 5 core questions with a 10-step process. So again, the current state of my assets, we have asset registry, performance and failure modes, residual life, and determine life cycle and replacement costs. Because really, if you can't get these basic details down in your assets, then you're not going to be able to manage them properly. What's my required level of service? Again, this is another step, and we have tools that correspond with these as well. Here we have your business risk. Now you see criticality. I cross that out. We prefer to use the term business risk. It's a more precise definition, in our opinion, where we look at the probability, or more correctly, likelihood of failure, multiplied times the consequence of failure, and then we have a mitigation factor, which altogether what we call the business risk exposure of your individual assets. Again, O&M and CIP investment strategies, we deal with these in detail in our program as well. And then finally, our funding strategy, and we build the asset management plan as we're going along. We don't really look at building the plan first and then doing things. We try to build this plan as we go along, so we don't have stopping to the process. And then this is decision-making focus, these last 4 steps here. We like to use these 5 core questions, 10 steps, because all these are able to assist the 3 fundamental management decisions in a water or wastewater utility, and they are, what are my work crews doing, and where are they doing it, and why, and which CIP projects should be done and when. And then we ask another critical question is when to repair, when to rehabilitate, and when to replace. And we believe these decisions typically account for at least 80% of the utility's annual expenditures. We had the SAM challenge in 5 tracks: communication, benchmarking, decision support tools, our remaining asset life track, and then our track 5 is our information technology. So we had started off here at a kickoff meeting with Virginia Tech and CSIRO team to review research plans, and so then we had them split up. So the first group is focused on prediction wastewater asset remaining life with international focus and expertise. Virginia Tech, their track was focused on data needs to develop models predicting remaining asset life with a North American focus. So we've had these two groups going simultaneously, and again, Professor Sinha can explain a little bit more about what they've been doing. You know, because we decided that decision maker communication, public outreach are important to success in this issue, and also we've had issues where there's been rehabilitation projects going, and having the public understand what you're doing has been gone a long ways towards acceptance of your work. Our track 2 is our leading practices and benchmarking. We did used the SAMGAP benchmarking tool to evaluate processes and practices to identify leading practice utilities, which led to a forum in 2010 where areas of excellence and best practices were presented to the group, and then they're also documented and included in the simple knowledge base. Our latest research in track 2 has been twofold. One, we had corresponding developing tools, condition assessment scoring, level service, life cycle costing, and CIP validation prioritization. We took these tools we developed in track 3 and had volunteer utilities go and use these tools and report back on the success of the tool in their asset management program. Most of the utilities all were leading practice utilities in these areas, and they found these tools really help support their practice. We've also had a maintenance key performance indicator track where we've, again, made a survey to try to understand what are the key performance indicators of high performance maintenance programs. So we define the leading practices, and we use questionnaires and then scored the utilities to evaluate them. We developed and distributed the document scoring mechanism to our subscribers, which they went and identified themselves via self-assessment, and then we followed up to validate it. We've had a case studies report that's in production right now, and then we're going to update our assessments based on lessons learned. A group statistics of the responding utilities, see we had 27 total utilities, and you can see the average number of populations served from the respondents was about 1 million. So these were large water and wastewater utilities here. Here's a sample of what our questionnaire looked like. You can see it rated your utility against, you can see your performance and also how it rated against the peers. Again, we use this to develop the leading practice utilities. So track 3 was our decision analysis and implementation program, and we used the 10-step process model, as we saw earlier, the 10 steps asset management. And the general subject areas covered were life cycle costing, your assets, valuation renewal, risk management, and then overall asset management. This document depicted here was kind of a how-to to identify the inhibitors and success factors in implementing an asset management program, and also organizing your information for your asset management. We wanted to develop guidance on implementing strategic asset management and also to provide tools. So it's organized around 2 elements: analytical and decision support tools, which were user-friendly and had a common structure and theme. And then we had an implementation tool to provide practical, accessible guidance for a tool to undertake strategic asset management incremental stages that led to a well-planned, structured, and progressive implementation to suit the needs of a diverse range of utilities. So we have a tool for each one of these steps, and we had the maintenance KPI survey tool for the O&M investments. Again, we have some tools, we have more than one. We have The risk tool, we have two different risk tools available in Simple. We also have a end of asset life reinvestment decision tool, which we have two versions of that. There's one version that's free of charge, and then we have another that's subscriber only. They don't vary all that much, and we should have the free version in Simple sometime around the first part of the year. One thing I should mention, though, is no one set of templates or spreadsheets can really capture all the elements that relate to the infinite number of variations and possibilities that a utility could need. So really these tools are intended as starting points about which an analysis could be crafted. And it's really unlikely a thorough and carefully considered analysis for a given real-world project would take the exact form of the core documents contained in the tool without modification. So for that reason, these templates and worksheets are not protected, so users can modify them as desired. Next, we'll just take a quick look at what a tool looks like. This is the Business Risk Exposure tool. All of our tools in our Simple knowledge base are structured identically. So we have the navigation bar on the left. Again, clicking on any of these boxes will take you to a set of decision logic diagrams. Again, we also have content here too, so the opening pages will always have content, and as you see, the decision trees will also have clickable boxes where it will take you to more content to explain it in detail. So here we have decision tree. Here we have the decision diamond here, usually a yes/no answer. We have workbook or template core tools, so this is where data entry goes. And then we have action boxes here too, and again, these are all clickable. Some of these will have small boxes in the corner where we'll give you more detailed information. Our remaining asset life track has turned out to be one that was really heavily desired by our subscribers, and really what we need to, because what we're trying to do in asset management is to manage the remaining life. So it's really critical that we determine how much life we have left. And what we were defining as the end of life, which we needed to get to first, is at what time a significant capital rather than operational investments made. So the key question is, when is it economic to replace the asset? So we developed a roadmap, areas of focus, which we felt the research was lacking. So individual asset state, network state, which we're kind of working on now in another project, modeling condition and performance. Again, these are things that the Virginia Tech team has worked on in the past and has some intention on continuing. Consequence and intervention analysis, economic decision making, which is something we'll get to in a minute, integrated planning, and knowledge management. We think the knowledge management, we've got a good start in Simple, but we still have some ways to go. One thing I want to talk about were the four primary failure modes as defined. We have capacity, where the volume exceeds design capacity. Level service, where the asset may work still, it just cannot meet the requirements that the stakeholders desire. Mortality, or technical or physical failure. Again, a consumption asset reduces performance below acceptable levels. And then efficiency, or economic, where the operation costs exceed that of the alternatives. And then we have some associated management strategies. One thing we like to say on this is we look to these failure modes, and for every asset is going to fail in one of these four ways. So the trick is to try to determine at which point will one of these kick in first, and those would be what we call the trigger points. We try to address these by one of our latest research reports, the Practitioner's Guide to Economic Decision Making. We wanted to show how economic analysis and the underlying concepts inform asset management decision making. We wanted to provide a way of thinking about asset management investments and provide practical guidance on a range of techniques applicable to each level of sophistication, both basic, intermediate, and advanced. And the focus has been on buried assets, but you can use these concepts on above ground assets as well. And it's in three parts: background on key concepts and basics, practical guidance, and then we provide case studies on how individual utilities applied some of these economic decision-making techniques. There was a range of issues to consider relating to risk and analysis of both the benefit and cost of different intervention options. And so this work really built on the roadmap and provides targeted guidance on what should be considered in an economic approach to asset management. And the guidance provides information on concepts, practical guidance. One thing, an economic decision making is another way of also talking about the triple bottom line as well. So we'll look at that. So the scope of the case studies, we had economics of service levels. We wanted to, set acceptable levels of service from a community and utility perspective, and economic assessment of rehab budgets. Again, the service levels, you're looking at a triple bottom line type analysis. The economics of reactive maintenance, determining when these approaches are acceptable and when planned maintenance approaches should be adopted and when the switch from reactive to planned should occur. And then we look at economics renewal or rehabilitation for specific assets. So really, what is the timing and selecting of the correct technique? And finally, we also want to look at the economics of alternative options as well. The remaining asset life data and modeling was something that was carried out by Virginia Tech, and they had several reports that were building up to the prediction models. So the failure modes and mechanisms were the standard data model and collection procedures to support the modeling. And as Professor Sinha can tell you, this was at first thought to be kind of an academic exercise, really set the table for what was to follow. But it turns out that our subscribers have really enjoyed this work because it gives a lot of parameters on what can affect a buried asset, and it goes through various details of intensity as far as data collection. But it turned out to be quite a good piece of work to help utilities start deciding what sort of data they need to collect in order to help them with their decision making. This led to a condition and performance rating scale that's been gaining acceptance throughout our subscriber base as well, and I'll leave it up to Dr. Sinha to give a little more explanation of this later in this presentation. And then finally, we wanted to develop a deterioration predictive models for the remaining economic life of pipes. Unfortunately, we had the basis, but we did not have the funding for this. So that's still something that we would like to go to finish up, and we're starting to find that the utilities are ready for this type of model as well. So we've completed the first two. We're still waiting to do the third. Finally, we get to track 5, which is our simple knowledge base. We had a framework for organizing and applying the asset management material called the Total Enterprise Asset Management Quality Framework. You can look in simple for more explanation of that. And we have guidelines for outlining best appropriate practices to match the quality framework elements. And then we have decision analysis tools contained in there. And we also have a training program organized around the 5 core question 10-step process, which is based on the Tom's Bad Day model done by the Advanced Asset Management Workshop. The content, there's about 16,000 pages in Simple, and I'll just give you, here's the opening page here. You can see the EPA training here, which is individually, there's about 11 modules, I believe. You can click on any one module to hear roughly a 50 to 1 hour long narrated slide presentation. This training is free to everyone, so I suggest if you want to just brush up on some tactics or get a little more in-depth information that's really worth checking out. You know, it was designed specifically for the wastewater industry, although it has some applicability. Of course, assets being assets, a lot of this applies to drinking water as well. You know, we have tools, we have guidelines, templates, interactive training aids, I mentioned, glossary of terms, and web links and general references. You know, it breaks asset management into 7 concepts, which is asset inventory, data standards, level service, risk and failure analysis, capital improvement plans, life cycle costs, and maintenance programs. So roughly 16,000 pages here, so it's enough to provide quite a wealth of information. We have another research program we've done separate from the subscriber-driven research, and this was called Innovation Research for Water Infrastructure for the 21st Century. This was a grant from the United States Environmental Protection Agency to WERF. It had 4 areas of concentration: condition assessment and system rehabilitation for water and wastewater systems, advanced design and engineering concepts, which was kind of a grab bag of other types of work, and then we had innovative treatment technologies, which was more of the you know, nutrient removal and digestion enhancements and things of that nature. One of the major projects that we funded under this was a interactive national database for drinking water and wastewater pipelines called Water ID. And now I'd like to turn this over to Professor Sinha of Virginia Tech, who was the principal investigator for this project, and he can fill you in on quite the amazing work that's been done there.
I have one question, Walter. You were describing that WERF is subscriber-driven, so this is quite an interesting thing. So what are the benefits and what are also the costs for the subscribers?
Well, the subscribers, because it's driven, we consult with our subscribers periodically about what types of issues they're facing and the type of research they'd like to have us do. And so that's how it's driven. Now they pay according to what their waste stream, how much they process. Okay. So that's the pay scale. So a small utility doesn't pay a lot, and of course some of the giant utilities like Chicago or Orange County, California, their subscriber fees are much higher, of course. But what we try to do is we try to make things that we you know, like I mentioned earlier, sometimes our investigators or subject matter experts will have some ideas, and we put them out to to our subscribers to see what the type of interest is. And then we also have circumstances where subscribers may come to us and say, look, we are having a particular issue in our systems, and we would like to have some research done, and can you help us get this research going? And what we do there is that we in essence, pass the hat. We notify other utilities about what one of our other subscribers would like to have done, and see if anybody else would like to contribute to the overall research. So that way, we're getting something done kind of outside of our normal process.
Mm-hmm. Do they get access to all those research reports and the databases?
Oh yes, they have full access to everything. We and also when we have these subscriber-driven. We call them targeted collaborative research. Okay. The utilities often serve on the review teams as well. Mm-hmm. So we make sure that everybody has full access, and we also have a fairly large number of volunteers that we get to help us review our research. You're on the one of our manhole projects, for example.
Okay, so Christoph Benescheid, he's now on, and with him is Hamid Beju from Algeria, and well, you've got a question, Christoph?
Yeah, I've got a question. Due to climate change, we are discussing different ways to manage the stormwater. So when the sewer is filled up completely with the stormwater, we naturally use the streets as a flow path for stormwater. Now there's a question: is it possible to implement these streets in your asset management model? Because you're using that, and possibly you have to pay for that. Is it possible to implement it in your model with the costs?
I would say any costs that can be put in, you could certainly apply. Now, like I said, we deal mainly with the wastewater, but when you think about it, an asset is an asset, and they may behave differently, but the management strategies, and possibly Professor Sinha can talk a little bit more about the transportation assets, but if you're trying to have an enterprise asset management program or a whole of government, certainly you could get the transportation sector involved with the other groups. I don't know if this really answered your question, but that's kind of what I was hearing.
It isn't yet solved in Germany, but it's you use it, and normally you have to pay for it. Possibly there are some damages when you use it. You have to construct it in a different way, then make some outlets into green areas, for example, and that's is something we discussed. We haven't found a solution for that, but it'd be interesting if there's a model, a way you manage it in the USA.
Oh, I see. Well, one of the things is when you start looking at the risk of an asset failure, and then you want to start looking at the cost of those risks, and of course when you have a collapse or something like that where it's damaging roads, those are costs that have to be considered in your failure model. So again, when you start looking at the risk individual assets or groups of assets pose, you want to look at the costs, which are really a direct consequence. One of the, like we say, one of the triple bottom line pieces is, of course, the costs or economic costs, along with the environmental and social costs. So if you start having assets fail that damage other infrastructure, the utilities here pay for those. But yeah, I agree, it's a huge problem, and really trying to develop a risk profile for your assets and really making sure that the ones that pose the highest, that have the highest business risk exposure are the ones that you deal with. That's the way we're trying to mitigate the damages.
Okay, thank you. I have one last question before we change to Professor Sinha. On one slide, you were describing the 10-step process, and that was very interesting because you were dealing with critical assets, you were dealing with the level of service, but also with questions of finance. My question here is, which I took from the chat, one question here. You go back to this slide. 10-step process. Yeah, there it is. Well, it's a quite I think it's a quite complex process. A lot of very important points to solve during this process. So, who, from your point of view, is responsible for the whole process? Is it the municipality who has to arrange this, or who is doing it? Because many different departments and many different stakeholders are certainly addressed by this process.
Yeah, I would say ideally, and of course it varied by utility, is you would have an asset manager who would be in charge of the overall program. Whether they follow these steps or another is up to them. But again, you would assign different pieces. The target level service is more of a strategic area. For example, when you're talking about what your stakeholders want. I mean, your stakeholders are not only the actual users, but also you have your regulatory agencies too. So they may set particular effluent levels which you have to meet. That has a cost. You may decide internally that you want to minimize your sanitary sewer overflows. Again, it can be done, but there's a cost. So once you have someone starting to set these sort of things on a strategic level, then you can, you have to start assigning it. So your asset registry, again, there may be some maintenance that's going to be involved in this. Your CMMS can help populate your asset registry. Your performance and failure modes, again, over time they can be determined. And that goes with the residual life and life cycle and replacement costs. So a lot of things are going on at the same time. What I would suggest for a good example of how this works on a real basis is to look at the Orange County Sanitation District Asset Management Plan in California. They have their asset management plan arranged around this 5-core question, 10-step model. Okay. And I would be glad to, provide some information. I'll send you the link where it can be downloaded. It's quite interesting. They also look at these on the asset level as well, where they talk about, condition, the risk, and things of that nature.
Okay, so you would say during the process for the different steps you need quite specialized departments who solve the problems, but then you need something like an asset management department, someone who is responsible for it, for the whole process, who maybe reports directly to the CEO of the utility.
Yes, that's really the way that we'd like to see it done. I mean, a truly asset-centric organization would have the asset manager at the center of the organization, although that may be the case in places like Australia and possibly in Europe. I don't believe it's like that in the United States, at least not on a large utility scale. But in Australia, it's more centered like that. But that's what we're working towards here.
What I'm going to present today is the Water ID, which is funded by U.S. EPA, Environmental Protection Agencies in U.S. Through WERF. And Water was the program manager for this Water ID. So what's Water ID? Water ID is a knowledge base, although we call it database, but there is no raw data there. It's not like a CCTV data or soil sample. What's there is, it's all case studies, and I will spend more time in going on the website, and I will also give you the address of the website. If you are in front of your computer, you can type in, it's www.waterid.org. So that's the Water ID. So why we developed this Water ID? The reason is it's an aging and deteriorating infrastructure. Just like anywhere in the world, in US this infrastructure is more than 100-year-old. It's way past its design life. And design life is not same as the performance life. So we'll talk about that. And the key is the condition assessment and renewal. The term we use, renewal in Water ID, that covers repair, rehabilitation, and replacement. So all under that umbrella we call renewal engineering. And the other important thing is in US, we have 50,000 water utilities, drinking water. Like in our transportation sector, if you look at the transportation department, they have the same problem. Their infrastructure is also aging, but we have only 50 Department of Transportation in US. But in water, we have 50,000. Some are so small that one guy, he cleans the driveway, he runs the pump, and he does the financial reporting. So that was the whole motivation behind developing this knowledge base or web-based database so that the knowledge can be shared. And it's very, very difficult. Most of these conferences or seminars, because of the tight budget in US now, most of these utilities, they don't go. And only their upper level staff, they go. And so that's also the other motivation of developing this. Another also important is utilities are not academic institutions, so they don't publish. A lot of their lesson learned or what they are doing, they don't publish like in academic, we publish papers or conference, they don't do that. And the most important is we live in information age. If you look at your kids and all those, they are in the Facebook all the time, they share information through the web. So having said that, that was the whole motivation of developing this Water ID. So the address I gave you, you can easily type. So there are two things here in the Water ID. One is the website. So that's freely available. I will show you. You can go to the website. You don't need any login. But if you really want to access the whole case studies, the cost information, what technology cost, how technology was used, what's the driver, what's going on in the asset management, then you need login. If you are a utility member anywhere in the world, if you send your official email from the utility, we will give you full access. If you are a consultant, technology provider, or service provider, the access level is different. Now, why it is like that? The reason is most of the utilities, they provided information, but some of the information they wanted to share only with utilities, or some of the information they only want to. So some of the information they only want to share with utilities, they don't want to share, so that's why we tagged in that way. So that's important, and I will show you in the website how to get this access. So like any database, there is a front end of the website, and then there is a back end. The back end is MySQL, so all data, if a utility is telling us that this information can only be shared with their own utility staff, we can tag in that way. Because even within the utilities, if you look at in the Washington, D.C. area, WSSC, that's in Laurel, Maryland, they have like 2,000 staff. And some of the documents they just want to share with their own utilities, and maybe among the other neighboring utilities, but not utilities even in US. So we can tag in that way. So that's why we developed this database. And I will show you more once I go into the website instead of showing you just the slides. So these are some of the access level, as you can see. And this website is developed with very close cooperation with the utilities, consultants, and technology provider. It's not an academic exercise. It's not like Virginia Tech just developed based on our academic, but we work very closely with more than 150 utilities in US, and then around 10 utilities in Canada, and there are 5 utilities in Australia, and few in Europe, and some in Asian country also, although it's very difficult to get the information or data from the Asian country. So how it works? It works is this is a living knowledge base, so information and knowledge comes all the time to us, and it comes to, you can upload, anyone can go and upload the information, then it comes, it doesn't show up directly in Water ID because like any, it's a kind of a library. All information comes in Water ID need to be tagged, and it needs to be tagged properly so that you can search this information or retrieve this information, what you want. So that's the basic structure of Water ID. So I will not go in detail. I don't think you can even read these slides, but basically what it's saying is this is how the information is tagged. Now Water ID is developed for water. There is no doubt in it. The EPA wanted for drinking water, wastewater, and now we are also going in storm water. But at the same time, what we felt is oil, gas, nuclear, other industry, they also have pipeline. And some of the technologies they use, maybe, I'm not saying directly we can take and apply to the water industry, but with some modification, we can apply. Some of the risk model developed in nuclear industry for nuclear piping is way advanced. And that we can learn from that how they use this risk ranking. Again, nuclear is regulated, it's a high risk, so they have invested a lot of money to do research and develop a risk model. But some of the philosophies, how they're developed, can be easily applied to our water industry. So that's why this whole Water ID also have knowledge. So this is the taxonomy, how technology, how these are classified. The key thing is it's a computer term, but it's very important to understand any information that comes to the Water ID need to be classified. Otherwise, you cannot find it, you cannot retrieve it. And so that's why we developed this taxonomy. Now, this is the first time in US any standard taxonomy was developed, and the industry helped us a lot to develop this. We engaged some of the Canadian and Australian researchers also to develop this taxonomy. And now that's how the information is tagged. So all these are strategic asset management is divided into sustainability, human asset management, physical asset, and others. So as you can see, the information is all tagged in a proper way so that you can search and retrieve easily. And models and tools are also done in the same way. What are the scientific drivers for any models and tools, how the data is managed. So this slide is giving you the understanding of how this research was done. Walter earlier mentioned this is Water ID is a unique project, And it's truly a unique project. We do a lot of research projects, but this project, first time we engaged a lot of industry and utilities. So the first one is IIRC, that's the innovative, that's from the EPA program, and WERF, they selected 20-member panel to review and provide feedback. And this was a 3-year project, so it's not like 6 months or 1-year project. It took us 3 years to develop this water ID. Then we also created database user group. And every month we use, just like net meeting, we are having meeting today, we had meeting every month to discuss with them what they like to see in the water ID. We also developing synthesis report, and Walter will talk, these are all free. Everything is free because it's funded by the federal government. And then we also have the technical review committee, looking at the content in the website. So that's what you can see here. So many people are involved and critically reviewing these websites in the development process. I'm just giving you some names of these DUG group, what we call database user group. You can see the people from utility and consultants were involved in that. Most of the utilities, but also few major consultants like CS2M Hill, Black & Veatch, they were involved in the development process of this water ID. So what is water ID? What I'm showing you is the front page. I will go to the website, live website, and show you how it works. So these are some of the testimony. We are getting a lot of good things we are hearing about this water ID. The people are using it and they are finding it. Now the whole purpose of this water ID is we are telling every utility is this is the information sharing platform. So if utilities come and contribute some information collectively, you can see a lot of good things are there. So that's we are asking every utilities. Right now I mentioned we have 150 utilities participating, more than 150, but not 50,000. And that's the challenge, how to engage. I mean, my wish is to engage all 50,000 utilities in US and also utilities in Europe, in Australia, and in Canada. So these are some of the utilities we have. So as you can see, it's not just in East Coast or West Coast. We got utilities throughout the US. And also from Hawaii, Alaska, we got pretty good. And in international, we have the few, mainly Australians and Canadians. We got few we got from Europe and few from Asia. And that's our now going forward. That's why we are having this webinar, so that we can engage more utilities, because more utilities will come, they'll share the information, is good for everyone. The synthesis report, I will show in the web, we are going to put synthesis. Now what is synthesis report? We develop many case studies in a technology, certain use of technology, we have like 10, 15 case studies. Then industry came and said that instead of reading 300 or 400 case studies, why can't you develop a synthesis report? What's going on in condition assessment? What's going on as far as renewal engineering is concerned? What's going on with utility engineering? The earlier question was how you collaborate with other transportation assets and other assets. So that's all those synthesis reports will be now available, and these will be all clickable. I will show you in the website. Then we also have product qualification, what utility do for product qualification, how they manage financial reporting, what models and tools work. The real challenge we are facing in US utilities are, there are hundreds of models are there. So challenge is not in the math, and the utilities, there is no reliability. Sometimes they use the model, sometimes it works, sometimes it doesn't work. And so how we know that these models, academic model or consultant developed model really works? So all those are there. Then if you see in the top level, sustainability, asset management, and resiliency. So how we know that what matrix you measure, what parameter you measure so that you can have sustainability metrics. What you do for resiliency, and that's the big thing coming in US, the resiliency parameters. Hurricane is coming, earthquake will come. So how we make sure that your water, drinking water or wastewater is going to work according to the performance, even if you get hurricane or you get earthquake. So that's the key. So these all synthesis reports will be published by WERF, and some of them are already there. You can go and download. These are all free. And this synthesis report is really good because it's a condensed version of what's there in water ID. So how Water ID works, before I go and show you the website. Water ID, we are also developing directly. We can extract information from the utility website. So we are promoting, just like in US we use hotel.com or orbit.com to book a flight or hotel. All information they get from the different hotels and provide service to the customer. So we are also trying the same way, that how we can extract certain basic information from each utilities and put it in a national database, so that we know what technology works, or what certain technology works in the East Coast doesn't work in the West Coast, like those kind of things. So that's the purpose of this. We are also trying to extract the information from the federal website. There's a lot of information is there which federal agencies, they are spending millions of dollars to collect, like soil, weather report, what's the weather pattern, and all this information is important for water utilities when they are developing their prediction model or decision models. So that service we are providing. So to wrap up, before I go to the Water ID website, the Water ID has a standardized data, it's a structure, and it requires communication. I mean, that's the key in any asset management is. It's not just the utilities. Utilities are doing good, but you also have to think from outside the box. Like certain things we saw, what Portland in the West Coast is doing for asset management is excellent. But certain things New York does in a good way, like their financial reporting. So why can't we share this information so that everyone becomes better, or they do good asset management? So that's the whole purpose of doing this asset management. So now I will go to the website before I come back and talk about the predictive model. So let me show you the website. So this is the Water ID website. Now, this website is free or open to anyone. You don't need a login. But if you haven't got access, so what you do is you go here. I mean, I'm already logged in, but if you go to www.waterid.org, there will be a box saying sign in, and you can provide us information and we will approve you. But use your official email, because if you are a utility member, you should have full access. And I will show you what the full access means. So this website, you can go and you can click. There a lot of information is there on the website on the top. All these public information is also available. You don't have to log in. So if you click here, and this is again for the US, we are going to develop this for the Canadians and Australian also. But right now, if you go and click, say, Virginia, then you get information from the Virginia, how many utilities, what. And as this information gets updated from EPA or from ASCE, the national database, this will get updated. So these are very general information about, you can click in any state and you can get this general information, what's going on. But if you go in the synthesis report, in the wastewater, earlier I mentioned synthesis report, you click condition assessment and it will take you to WERF website. And then you can download from there these reports. And these are all free reports. So that's for the synthesis report. Case study is the same way. You go to the national, you want category, you can select whether you want drinking water, storm water, whatever you want, cost. So you click condition assessment, you want Portland, these are the case studies. The only issue is if you are not logged in, then you only get to see the abstract. Then login information is required. That's the only thing is if you are not logged in. If you are logged in, then you have full access to everything. You can download any material from here, and there are thousands of materials are there. So that's the international is the same way. You click international, you can go and look for, say, the Korea or Sydney, Australia. If you go, so you can click and you can download this information. Then you come down, and we are developing, earlier I mentioned the stormwater management, we are developing energy pipeline. These are all under development, so a lot of information will come. All these house is clickable. You can click anything, performance management. Earlier Walter was talking about benchmarking. Now this benchmarking is, only you will see is the general information for this benchmarking. If you really want each utility, you have to log in, and then you can find for the utility benchmarking. So I will show you quickly. You go down, and if you click here, the results for the benchmarking. So what you are seeing is water resource utilization, employee information, physical. So water resource utilization, you click in. So what you are seeing is a very general. But if you are a utility and if you have provided your data, then you can log in and you can see your own, and then you can compare with your peer other utilities what they are doing. So that's a big advantage in this database. It's very interactive, and you can use this in many ways. So all these are clickable. So I will show you just one condition assessment if you click. Now, any technology provider, they want to showcase their technology, they can come and upload the information and it will show up. It doesn't go through the review process. So like this solo robo, these are the new kind of robos developed. So they can come and they can upload. We don't review this. But if a technology provider is going to provide a case study related to use of the technology, what it costs from the utility perspective, then it has to go through the review process. It will not show up in the water ID. So that's the difference. If you have any new technology, you can show up there. And you can filter and you can search the technology. There are hundreds of technologies out there. So you can filter, and these are being added. This is a living knowledge base. So that's the advantage of this whole water ID. And there are a lot of other links. So you have to just go there and look at. So all these what I showed you is available. You don't need login. Now the key comes is what happens when you log in. Once you log in, all this search and navigation will work. These tabs will not work if you are not logged in. And also these will not work. Submit data. You can submit data in many ways to the water ID. Some will show up right away without review, but some need to go through the review process before it can show up in the water. So I will quickly go and show you some of the search. So there are many different search. What we learned is that utility, they look for information in a different way. If you are a manager in the utility, you look for information in a very different way than an operator will look for information. So that's why we developed many different ways to find information. Facet search is very similar when you go to, like here, grocery store, Macy's.com or BestBuy.com. You are searching and browsing at the same time. So I will show you one. Basic is very simple, like Google search. You type in the keyword and it will throw you thousands. So facet search is interesting because say I type CCTV. CCTV is very common in wastewater. So now you see what's going on is it's throwing you a lot of information on CCTV, but it's also filtering. So you are searching and browsing at the same time. In gas, these are all case studies. So in water side, even in the water, you need to divide by wastewater, drinking water, storm water, industrial use. So all these gray water use. So how these are used, you can search and you can narrow your search again. So when you go in the wastewater, now you see your search is narrowed now again. In the water mains or laterals or force main, what different kinds you want. And so that's the beauty of this database is. It's not just uploading the information, but also how you retrieve information. We also develop navigation. And I will show you one quickly navigation. If you go to the technology class, go for condition assessment, then you can look for acoustics or any sonic or ultrasonic impact echo, whatever you want, you click there, and then you go to the profile, and as you keep going down, the cost information is there, case study is there, everything you can get through this website. So that's the whole purpose of this. Bid informations are there, you can find the bid, any bid, and these are all public documents, so from all utilities, it's all coming to the water ID. Case studies I showed you earlier, the case studies you can find by wastewater or drinking water side. In the wastewater, if you click, then it brings this rubric. Whether you want case studies related to strategic asset management, tactical, operational, you want renewal related, condition assessment. So in many ways you can search. And that's the key in water ID is that it's not just information upload, but you should also be able to retrieve information in a timely and right way. You shouldn't feel frustrated. If you are looking for something in the utilities, you want your force main to be inspected, you are looking for a technology, or you are looking for a rehabilitation technology, you should be able to find right away. So that's the whole purpose of this water ID. So that's in the nutshell. Again, I would encourage you to go and I will log out and I will show you how it works here. So create new account. So just press that or request new password, whatever you want. You create new account, you click that, give us some information, use your official email, we will give you access right away. So and that's, I think everyone should be encouraged to go and look at this water ID and see the strength of this water ID. So let me go back to my slide and I will wrap up with the prediction model. That's the project we are doing. Water ID earlier I mentioned is the knowledge database. Everything there is based on case studies, based on information provided by the utilities, reviewed by the utilities, reviewed by the technical panel, and then we upload. Any technology description, one-page flyer or two-page, we don't review. That goes right away, and that's a commercial, so there is no claim there that this technology will work or how much it costs. Whatever vendor is providing, we are providing you that. So other is the prediction or deterioration model Walter earlier mentioned. We worked in the project with WERF phase 1, where we said what data we should collect to support prediction model. Now prediction is very challenging, especially in US. We don't have good data here. We don't even understand how these pipes they fail. Now, we have a lot of heuristic model. Some of the utility folks working for 30 years, 40 years, they think that they know how this pipe fails. But you will be surprised. A lot of parameters we don't understand. The same pipe in certain area in US, 100 years, 200 years is fine. But in certain areas, deteriorating within 20, 30 years. I will give you a simple example in Atlanta. In Atlanta, concrete wastewater pipe in certain area was falling apart. We looked at all parameters. We looked at why it is going. We looked at the loading. What we found is that in certain area, pipe, it was 100-year-old. At that time, the street was just a minor street. Now it has become interstate highway. The loading has changed 40% in that area. Pipe was never designed to take that much load. So that in some area we saw contractor didn't do a good job. The bedding was not right. The pipe was sitting on the rock. So there are a lot of things is going on, and that's the key is that how to develop a good prediction model so that we can predict the remaining economic life. I mean, it has to be a physical. First, you need to start with the physical and then go with the economic life. So that's we are trying to do, and Walter earlier mentioned that WERF is interested. We are talking with the utilities. That's what they want, to predict the life of their pipe. So this is, in a nutshell, phase 1 is completed. Now we know, I mean, I'm not saying 100%, but with 90% reliability, we know what critical parameters are. That we did in the phase 1. Phase 2, we developed a good, robust index. Index is also very important. If you look at the CCTV, in US, we have PSCP coding, which came from, actually from UK, WRC coding. It's based on CCTV camera. You send inside the pipe, and then you code in a 1 to 5 scale. Now the challenge is these are defect coding. The CCTV camera goes inside the pipe. If you don't see any defect, then you say it's good pipe. Now that's really problematic, because the pipe maybe crack has started from the outer surface. Camera cannot detect that. Or if a metal pipe is there, corrosion has started. So that's we developed that is you cannot just look at this defect index. You have to combine. Defect index is good because that's the truth. If a pipe is already fractured or hole is there, that's a hole, that's the truth. But if you don't see anything, that's a challenge. And then they say that we didn't see anything and the pipe failed in 6 months. Yeah, pipe failed is because camera just give you superficial defect index. So that's where we develop. Now we want to move that scale with time. Even if you see a crack, maybe that crack can live for 10 years, 20 years. So why you bother to go and fix that? So that's the phase 3. We are going to work on that. So that ends my, if you have any question before I hand over to Walter.
I was just thanking Sunil for this wonderful presentation. It's a lot to learn, a lot of data you are managing in Water ID, but also a lot of experience with regard to models. And I think there are some questions with regard to your presentation. And one is, I think it's quite interesting to see that you are talking about deterioration models, not only for the technical or for the physical life, but for the economic life. I think that's something new, and my question is the problem in developing the right models, or is it more in gathering the right data? I think it's
right. That's a very interesting question, Bert. I mean, the challenge, we don't see the challenges in mathematics. I mean, there are a lot of mathematics is like a tool, like a filter. I mean, these are digital filters. The real challenge we are facing is good data. Most of the data utility, they have like a one-shot data. There is a problem, they go and collect that data. We don't have a good time-dependent data. As you know, any modeler will tell you, to develop a good model with reliability, what you need is a good time-dependent data and also the whole verification and validation process. And that's the challenge we are facing right now. We don't have the good data from the field. We don't, in the lab, when you do some experiment at the scale level, that doesn't represent the real world scenario because it's not like a transportation. These pipes are buried in different environment. To mimic that scenario is the real challenge.
Mm-hmm. And there were many tools to cope with this subject, and I think you must have, there should have been a lot of contacts with different utilities and a lot of discussion during the development of these tools. What would you say is the major obstacle to the implementation of a good asset management for utilities or for municipalities? What are the major obstacles? What are the key issues? I think it's not just data, there must be also other obstacles.
I mean, if you just ask me one thing, I will say culture change. Because culture needs to be changed. The guy who's working for 30 years or 40 years in any utilities, that person doesn't want to change. I mean, that's the human nature. So that's the key is we need new breed of engineers. We need someone to look holistically. Traditionally in US, if you look at that, asset management was not there. I mean, everyone was managing their own. A guy who's running the pump, a person who's in charge of the construction, or in the department who's in charge of renewal, they were not talking to each other. It was a very silo kind of a functioning. Now they have to work together because it's not just a matter of going and rehabilitating. You need to understand that what was the condition, what is the history behind this, and under what condition this pipe was laid in before you go and do rehabilitation. So asset management is a teamwork. And that what we are seeing is it's a challenge for some of the person working in the utilities for 40 years. That person is so siloed, want to work in one domain. So I think that's the one thing I'm seeing, that culture. And some utilities are doing good in asset management because there is a leadership. One guy is driving and then all other are buying in. So other than math and modeling and tools, that's the different domain. But if you ask me one big thing, I think you need leadership to drive this whole asset management.
Okay, so before we pass the microphone to all participants in turn for the last round, one question still. That are quite impressive systems and tools that we've seen. And Walter, you have also mentioned that you are offering training courses or these IPA training is also on the website. So is it only training, or are you also offering a kind of certification for asset management so that you get a degree as an asset manager or something like this? Are you offering this as WERF, as Water Environment Research Foundation?
Well, no, that's an interesting question, though. Actually, Professor Sinha has a certificate program at Virginia Tech based on the 5 core question, 10-step process. He could probably give you a little more of an insight on that.
So this is the water idea I was showing. If you go to the swim certificate, and if you click swim certificate, that's the certificate program. And it's sponsored by EPA and WERF.
Okay. The focus is on water and wastewater, both.
It's water and wastewater, and the instructor is Duncan Rose from GHD and Steve Albee from EPA.
Yeah. Okay, thank you very much. As far as I can see, there are no more questions here in the chat, so well, it was a quite good webinar today. We had some wonderful presentations from Walter Graf and from Sunil Sinha. Both of you, thank you very much for your presentations and for all the information you've given to us. Water ID is certainly a very interesting and useful platform, and I'm curious about how it is going to develop in the future. So thank you very much. Also, Many thanks to all of you. Thank you for participating and for your questions and contributions. And let's take a look what's coming up next. So it was very nice to have you all here with us during this 5th webinar for our series on asset management. And if you want to stay in touch with our group, it's easy to do so. Just join our group on LinkedIn. It's called IKT Asset Management of Underground Infrastructure. It's set up especially for the participants of this webinar. In any case, I hope we meet again during our next webinar session on 9th of December, once again a Monday at the same time, 9 a.m. Eastern or 1500 Central European time. So I say goodbye to all of you, and don't forget, even if it's already late, it's cold and it's getting dark here in Europe. As you can see from my window, we all know the sun has just been rising in California. So goodbye.